Today we're going to go ahead and introduce trigonometry by looking at marking the triangle and writing trig ratios. So actually we're going to start by revisiting Pythagorean Theorem. So we've got our right triangle. With Pythagorean Theorem, you got to know where the hypotenuse is and where the two legs are. So one thing I like to do to find the hypotenuse is to go ahead and draw an arrow from the right angle to the opposite side. That gives us the hypotenuse. That means the other two parts are the legs. So you might remember Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. I go ahead and just write that as L squared plus L squared equals H squared. Now I realize some of you may have learned this as A squared plus B squared equals C squared. I get it. That's the way I was taught. I actually taught that myself for a while, right up until I realized, that's the stupid way to do it. Why would you let A equal leg, and B equal leg, and C equal hypotenuse? Isn't it a little easier if we just let L equal leg and H equals hypotenuse? That's the way I like to do it now. Alright, so why bring up Pythagorean theorem? Because the idea of having legs and the hypotenuse, these are key vocabulary for trigonometry. So let's go ahead and take a look at how this works with trigonometry. We still have the same hypotenuse, and you can still find it by drawing your arrow and labeling it. Now we still have two legs, but in trigonometry, there's actually specific names for each leg, and it depends on which angle you're coming from. So let's say we're going to go from angle A in this right triangle. One of our legs is now referred to as the opposite leg. And to find the opposite leg, go ahead and draw an arrow from angle A to the opposite side. That gives you the opposite leg. And then the other leg is now referred to as the adjacent leg. So this is how we go ahead and mark our right triangle to prepare to use trigonometry. Let's go ahead and practice it one more time. Alright, so first we'll start with triangle on the left. Notice that we have to know what angle we're coming from. So on the left triangle, we're going to go ahead and go from angle A. So first step, go ahead and find your hypotenuse. You can go ahead and draw an arrow from your right angle to the opposite side. That will give you your hypotenuse, which I'm going to be abbreviating at this point. Next up, we need to find our opposite leg. So go ahead and draw an arrow from angle A over to that opposite leg and label it. I'm just going to abbreviate at this point. This means that our third side is our adjacent leg. So abbreviate that, and now we have fully marked our right triangle on the left side. All right, your turn. Can you go ahead and label the right triangle on the right side? Realize that this time we're going to come from angle B. Go ahead and pause the video and give it a try. All right, let's go ahead and check if you got this. First, you can draw your arrow from the right angle. That's your hypotenuse. Next up, you're going to draw an arrow from point B to the opposite side. Now we got our opposite leg down on the bottom, which means the last leg is the adjacent leg on the right side from B to C. So notice the hypotenuse is the same, but the opposite leg and the adjacent leg, they switch places when we switch the angles that we're coming from. Now it's time to take a look at our three main trig ratios. And they are sine, cosine, and tangent. Now, these are ratios, which means they're actually fractions. So each one's a different type of fraction based on what sides you're using. So sine is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse. And finally, tangent is the opposite leg over the adjacent leg. Now, there's an easy way to remember these three really important trig ratios, and that is so, ka, toa. To help you remember this for a really long time, go ahead and sing it with me. Soka toa, soka toa. Alright, that was fun. Since these are ratios, I actually don't like to write it that way. I like to go ahead and take my opposite leg and hypotenuse and actually write it as a ratio. So I want to write so like that. And then follow through, and ka will be like this, and toa is like that. So there you go. Our three main ratios. So, ka, and toa. How do the trig ratios work with the triangles? Well, we got our marked up triangles there. Let's put our heads together and write up some trig ratios. Let's start with sine of A. So first we have to realize that sine of A means we are thinking of so. It's going to be a ratio, and so we've got opposite on top, hypotenuse on the bottom. So in this figure, we've got BC as the opposite side, and AB is the hypotenuse. So that's going to be our sine of A. On the other side, what if we want to do tangent of B? Well, tangent means we're thinking toa. So that means we would have a ratio with AC on top and BC on the bottom. Now we're going to go ahead and add some numbers, but the first thing you might notice is it doesn't say sine, cosine, and tangent anymore. Those are the abbreviations for sine, cosine, and tangent. So when you see sin, that just means sine. When you see cos, that's cosine, and tan is tangent. So if you want to sound professional, when you see sin, don't say sin, say sine. And don't call it cos of A, call it cosine of A. All right, so first off, we're missing one of the sides. So we're actually going to go ahead and solve for that side. So we can call that x if we want. And this is a Pythagorean Theorem problem. So we got to find our hypotenuse. The other two sides are legs. And now we're going to do L squared plus L squared equals H squared to solve for that missing side. So we got x squared plus 3 squared equals 5 squared. And then we go ahead and just simplify that out. And we end up with x equals 4. Now, I've run out of space, so I'm going to go ahead and erase all that. And now we're ready for our SOHCAHTOA. So we got to mark our sides. We have our hypotenuse. To get the first set of problems done, notice they all come from angle A. So we got to mark the opposite side from angle A. And then the third side is adjacent. And you notice I did another abbreviation. Now I have just HO and A. All right, so how do we solve these? We have to think of SOHCAHTOA. So with that in mind, if we want sine of A, that's going to be opposite over hypotenuse, which I'll go ahead and highlight for this one. And that means we can just write 4 over 5 for the sine of A. It follows that 3 over 5 would be our cosine of A, our adjacent over hypotenuse, and the tangent is 4/3. All right, so now we got all the ones coming off of angle B. So your option here, you can erase what you did for marking the opposite and adjacent, or you can just redraw a triangle. So I'm going to redraw a triangle. And if you want, pause the video, mark up that triangle from angle B, and write down your ratios for sine of B, cosine of B, and tangent of B. All right, let's check it. So hypotenuse is the same side. This time you draw your arrow from angle B to the opposite side, and that leaves the 4 as your adjacent side. So now we use this triangle to answer our last 3 problems. You should have gotten a sine of b as 3 over 5. A cosine of b is 4 over 5. And the tangent of b is 3 over 4. Now you're actually given one of the trig ratios, and you need to determine a different one. So we know cosine of a is 5/7. So we got to start by marking our triangle with hypotenuse opposite from a and adjacent. Since this is cosine, we have to think ca, which means adjacent side is the 5, and the hypotenuse would be 7. So now we got to find the missing side, and this is Pythagorean Theorem problem. So we set it up, x squared plus 5 squared equals 7 squared, simplify it out, and we end up with x equals radical 24. Alright, so now I'm going to go ahead and redraw my triangle, because this time I'm going to do tangent of b, I need to remark it. So hypotenuse is the same, but now the opposite side is the 5, and the adjacent side is radical 24. So TOA is what we're going to use for tangent, and that means that my tangent of b is going to be opposite on top is now 5 over radical 24 for the adjacent. So that's an answer. It kind of works, although most of the time math teachers would like you to simplify it and not have a radical on the bottom. So if I multiply the top and the bottom by radical 24 over radical 24, I get 5 radical 24 over 24. Now there is some more simplifying we can do with radical 24, but I'm not going to go over that on this problem at this time. Time for practice problems. So you should be pausing the video when you see the problem, work it out, and then go ahead and hit play, and you can check your answers. Here's your answer for problem 1. Go ahead and hit pause and try this last problem.